Hello everyone, welcome again to my home, and today I'd like to talk to you about the function of the cranial nerves. This topic relates to one of our core concepts in the field of neuroscience. It's core concept number 1, that the brain is the body's most complex organ. And the complexity we're going to explore today concerns the functions of the 12 cranial nerves. My learning objectives for you today are first, that you would discuss the functions of the cranial nerves in terms of the sensory and motor signals that are conveyed by each nerve. Some of them will convey only sensory signals, some just motor signals, and others both. I also want you to be able to discuss the relationship between the cranial nerves and the corresponding nuclei within the brainstem that either receive signals from those cranial nerves or give rise to axons that grow out and form those nerves. Well, in a previous tutorial, you've had the chance to look at the cranial nerves on the actual human brainstem, as well as to study them, I trust, in this illustration from our textbook that we've been reading along the way. This is from the appendix, figure A7, and this figure lays out for you the cranial nerves that attach to the brainstem. There's no olfactory nerve here because the olfactory nerve does not attach to the brainstem, but we do have our optic nerve, which attaches actually to the forebrain, to the diencephalon, not to the brainstem, but it's included in this illustration because of its proximity to the brainstem. And then the rest of these nerves, 3 through 12, do indeed attach to the brainstem. They are the oculomotor nerve, number 3, the trochlear nerve, number 4, the trigeminal nerve, number 5, the abducens nerve, number 6, the facial nerve, the vestibulocochlear nerve, nerves number 7 and 8, the glossopharyngeal nerve, the vagus nerve, the spinal accessory nerve, and finally the hypoglossal nerve. So, if you need a visual reminder, I would point you back to the tutorial that was presented in week 1 that refers you to the anatomy of the brain stem as viewed in an actual human specimen. And there you can find a couple of different tutorials that identify these cranial nerves as they attach to the brain stem. Part of our challenge that we're building towards with this tutorial is to try to get to the point where we're able to relate those nerves to the set of gray matter structures within the brainstem that either receive the incoming sensory signals or give rise to outgoing motor signals. Now, I know this figure must look like a monster to you, and indeed it's rather onerous, but it's an attempt to represent for you the 16 or 18, depending upon how you want to count them up, nuclei within the brainstem that are related to these cranial nerves. So we're not going to take this challenge on full bore right now. We'll do that progressively over a few tutorials. Rather, what I want to be able to do for you is give you a way to understand the function of the nerves so that we can then get into the brainstem and recognize how the gray matter nuclei help to explain the functional differentiation of the various components of each nerve. So here's how I'd like to do that. I'd like to build for you out this table. And in this table, I've organized the content, that is the function of the cranial nerves, into motor components and sensory components. Now, notice that I'm focusing on just nerves 3 through 12, so what I'm leaving off here is nerves 1 and 2. Those are the 2 nerves that don't attach to the brainstem. Just for completeness, let me tell you what they are now, and then we won't return to them. Nerve 1 is the olfactory nerve. These are the axons that grow from our olfactory sensory cells in the nasal epithelium through the cribriform plate at the anterior floor of the cranium and make synaptic connections into the olfactory bulb. That's nerve 1. Nerve 2 is the optic nerve. The optic nerve grows out from retinal ganglion cells. These are the neurons in the inner layer of the retina that extend their axons back to the diencephalon and to the very upper part of the midbrain. We'll get back and talk more about that later. Okay, so nerves 3 through 12, these are the ones that fully attach to the brainstem. And notice how they've been further differentiated. On the motor side, we've recognized 3 divisions of motor outflow, which is a reflection of the embryology of the developing nervous system in relation to the developing targets of these motor axons. We can recognize somatic motor nuclei. So these are nuclei that contain the motor neurons that innervate the muscles that are derived from embryological somites. We have branchial motor nuclei. These are nuclei that contain motor neurons that grow out and innervate the muscles derived from the pharyngeal arches in the developing embryos. These are called branchiomeres, and from those branchiomeres develop a set of structures in the cranial region and in the neck. Some of them are muscle, and some of those muscles are innervated by nuclei that come to occupy a distinct position in the brainstem. So these we call our branchial motor nuclei. And then lastly, on the motor side, we have visceral motor nuclei in the brainstem. And so these are the preganglionic parasympathetic neurons that provide outflow from the central nervous system to ganglia associated with end visceral organs. And then from there, there's a ganglionic neuron that actually innervates the end target, be it smooth muscle or cardiac muscle. Well, that's on the motor side. On the sensory side, we have subdivisions that will also help us to organize our understanding of these nerves and their functions, and eventually how that relates back to the brainstem. There is a special visceral sensory function associated with some of the cranial nerves, and that function is taste, or a little bit more technically, gustation. So we want to recognize which nerves convey our sense of taste to the brain. There's a more general visceral sensation that comes from some cells that are associated with the carotid body as well as the aortic arch. And depending upon how we want to think about that, we can also consider the mucous lining of the oral pharynx as part of this general visceral sensation. Okay. We have next somatic sensation, which would include those structures that are in the peripheral parts of our body, namely our skin surfaces, our muscles, our joints, our tendons. So from these somatic structures are derived sensory signals that feed into the brainstem, specifically from the region of the head and the neck. And then lastly, in the cranial region, we have special sensory systems. And there are some that attach to the brainstem, specifically first-order afferents that are concerned with our sense of hearing and our sense of balance. Okay, so this is the embryological framework that we're going to apply. What I'd like to do next is just walk through nerves 3 through 12 and identify which components we find associated with each. So beginning with nerve 3, our ocular motor nerve. What we have in the ocular motor nerve is a somatic motor function and a visceral motor function. The somatic motor function of nerve 3, the ocular motor nerve, concerns the outflow to the orbital muscles that move the eyes, and also to a muscle that elevates the eyelid. On the visceral motor side, the outflow through the third nerve is a parasympathetic preganglionic outflow that's involved in constricting the pupil. We'll come back and talk more about that when we consider the pupillary light reflex. Okay, nerve 4 is the trochlear nerve. It has a single component. It's a somatic motor outflow. The trochlear nerve innervates the superior oblique muscle, one of those muscles in the orbit. This is a muscle that turns the eye inward and downward. Nerve 5 has two components. It has a branchial motor component. It supplies motor outflow to the muscles of mastication. That is, our chewing muscles. So these are muscles that are derived from the pharyngeal arches. There's also a sensory component in nerve 5. This is a general somatic sensory component derived from much of the face. And our sense of touch, our sense of movement of the face. This is conveyed via the trigeminal nerve, in addition to some others, but the trigeminal nerve is the most significant of the cranial nerves, providing incoming general somatic sensation. Nerve 6, like nerve 4, only provides a single somatic motor output to one muscle in the orbit. And nerve 6 is the abducens nerve, and the muscle it innervates is the lateral rectus, which abducts or abducts the eye, moving the eye laterally. Now, nerve 7 is one of the more complicated nerves that we have, and as you'll see, there are numerous components to nerve 7, so let's talk about them in turn. First, with the brachial motor component. This is perhaps the most memorable. So, nerve 7 is the facial nerve. It is the nerve that supplies the muscles of facial expression. So those muscles are derived from the pharyngeal arches, and it is branchiomeric. There is also a parasympathetic outflow to numerous glands in the cranial region, the lacrimal glands, as well as the salivary glands, except for the parotid, which is supplied by a different nerve. So that's the parasympathetic outflow from the facial nerve. There's a special visceral signal coming from the anterior two-thirds of the tongue that passes through the facial nerve. So this is information about taste or gustation conveyed via the facial nerve. And then there is a general somatic sensory component derived from a small patch of skin in the ear. Okay, nerve 8 is a sensory nerve. And I have two circles way off to the right-hand column for special sensation for nerve 8, because there are really two components that are passed through this nerve. There's a hearing component conveyed from the cochlea, and a balance or equilibrium component derived from the vestibular labyrinth. And it's worth putting two check marks separately here in this box for nerve 8, because these two divisions of the nerve will innervate different sets of nuclei in the brainstem. Okay, nerve 9, the glossopharyngeal, is one of the most complicated nerves that we have. Even one more check than what we had for nerve 7. So again, let's walk through the glossopharyngeal systematically, beginning with the brachiomotor component. So as the name implies, there's innervation of muscles around the pharynx out from nerve 9. That gives us the pharyngeal component of the glossopharyngeal. There is a parasympathetic outflow in nerve 9 to the parotid gland, one of our salivary glands. There's a special visceral sense that's derived from the posterior one-third or so of the tongue. So this is our sense of taste being conveyed from taste buds in that posterior region of the tongue. There is a interesting general visceral sensory signal that is conveyed via the glossopharyngeal nerve, and this is coming from the carotid bodies, which are chemosensory structures associated with the bifurcation of the common carotid into its internal and external parts. And so this is very important in regulating blood pressure. The carotid bodies are important for sensing the chemical composition of the blood, which then can feed back into the regulation of blood pressure, of cardiac output, as well as respiration rate. So these signals feed into the brainstem via the glossopharyngeal nerve, and this is what we have in mind when we talk about our visceral sensory element here. Now there's a somatic sensory component as well, also derived from a small patch of skin in the external ear, and that accounts for these 5 components of the glossopharyngeal. Now, the next nerve we have is the vagus nerve. Like the glossopharyngeal, it also has 5 components. And beginning with the brachiomotor component, the vagus provides some innervation to muscles in the posterior pharynx and in the region of the larynx. There's a parasympathetic outflow in the vagus nerve, of course. This is the one that you're probably thinking about when you think about the vagus nerve. There's outflow to viscera in the thorax and in the upper part of the abdomen. And much of that outflow is derived from a couple of nuclei in the brainstem. There is also a sense of taste that's conveyed via the vagus nerve. It's not quite as important as nerve 7 and 9, but it's there. It's from some taste buds that are in the posterior part of the oral cavity. There is a visceral sensory signal conveyed via the vagus nerve. It also has to do with regulating the cardiovascular system, and it has to do with sending signals from the region of the aortic arch that are sensitive to stretch, as well as sensitive to the chemical composition of the blood in that region. And lastly, like nerves 7 and 9, there's some innervation to a patch of skin around the external auditory meatus. So I want you to notice that nerves 7, 9, and 10 are all very complicated nerves. They're mixed nerves. They're mixed with multiple subcomponents for motor control and sensory processing. But they are complicated in very similar ways. So hopefully that will help you in your understanding of these nerves. All right, so the last two are a lot simpler. Nerve 11 is the spinal accessory nerve. It also has two check marks because this nerve provides for branchial motor output to two different muscles, the upper part of the trapezius muscle and the sternocleidomastoid muscle. These are muscles involved in turning the head and shrugging the shoulders. And then lastly, the hypoglossal nerve, nerve 12, supplies for a somatic motor output to the tongue muscles, and this is the nerve that's involved in sticking your tongue out.